In part 1 of our series, we created a virtual one-dimensional being named Dot, who could learn to survive in RingWorld by using a simple neural network. We begin to translate from the genetic approach of NEAT into TensorFlow. Our first step is to replace each Dot's custom neural net with TensorFlow models. Having dozens of models running simultaneously is not how TensorFlow models are normally used. It's more typical for large sets of data to be fed through a single model. In our first attempt, each TensorFlow model can make decisions from input, but all learning and fitting is still handled by NEAT, neuroevolution of augmenting topologies. The models learn to seek the food and avoid the enemy by trial and error. Running hundreds of dots using individual TensorFlow models was far heavier than custom NEAT, so our population was limited to 35. The first TensorFlow model we try is made of 3 layers. An input layer that accepts dots' left and right vision, a dense layer that has 2 nodes, and an output layer that applies a softmax function. A life counter was added to inhibit dots from merely shadowing the enemy. The scatter plots show the 2D tensor vision inputs in a grid. This set of 2D tensors chart what the best dots see in a generation in the left and right directions. Positive values indicate food at that distance, negative means the enemy. Patterns emerge from the scatter plot graphs. Strong lines develop along the axis, where Dot could see nothing along that direction, and thus the vector was set to 0.
Say that you're leaving, thin as a shadow. Don't walk away, there's still waters to travel. Planted a garden, filled it with flowers. We dug a hole, now we're praying for showers.
2 zones remain clear, the positive and negative quadrants.
Found you some new shoes.
This makes sense, because neither the food nor the enemy could simultaneously be in both directions.
Ring, 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 we have all the things we need to make it work. Ding, 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 please don't give up even though I know it hurts. Tweet, 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 listen to the happy flying birds outside. Let their song fill you up. We are young and we have. Say that you're leaving, fat as an apple. Don't walk away, I can't eat well without you. We built a new house for our pet mouse. Now he is home, the roof keeps out the owls. Went to the movies, got us the best seat. Don't fall asleep, monsters are really scary. Please don't give up even though I know it hurts. Tweet, 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 listen to the happy flying birds outside. Let their song fill you up. We are young and we are I think we can, oh yes we can. I think we can, I know we can, oh yes we can. I think we can, I know we can.
The patterns in the scatter plot make best dots decisions clear. Lines that gain food drive the vectors from a positive number towards 0. Avoiding the enemy means keeping negative vectors from approaching their 0 axis.
Ring, 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 we have all the things we need to make it work. Ding, 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 please don't give up even though I know it hurts. Tweet, 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 listen to the happy flying birds outside. Let their song fill you up. We are young and we have plenty of time. We have all the things we need to make it work. Ding, 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 please don't give up even though I know it hurts. Tweet, 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 listen to the happy flying birds outside. Let their song fill you up. We are young and we have plenty of time.
Obviously, TensorFlow models were not meant to be used this way. RingWorld Part 3 will demonstrate fitting our models to ideal choices made by the best dot of the last generation. Each dot already maintains a thought log, storing each cycle's vision inputs and decision outputs that can serve as training sets. More efficient use of models should also improve the performance of using TensorFlow experimentally. Better garbage collection, asynchronous calls, GPU acceleration and a compound brain model could provide a generous performance boost. Thank you for watching me learn.